Bismillahirrahmanirrahim. How are you, students? Today we will start a new chapter, unit number 9, class first year. Unit number 9, class first year. The name of chapter is Physical Optics. Physical Optics. Subject Physics. Lecture number 37. Before going into detail of this chapter, first we will explain what is optics. Optics is the branch. Optical physics is the branch of science that studies the behavior and properties of light, in which we study properties of light, including its interaction with matter and the construction of instruments that use or detect it. Optics usually describe the behavior of visible, ultraviolet, and infrared light. So we study properties of light. Properties of light and study of instruments which give information about light. So in this branch mostly we study visible light, ultraviolet light, infrared light. In this we study also nature of light. Nature of light, whether it have wave nature or particle nature. We study these things. Nature of light. Light is transverse electromagnetic wave that can be seen by the typical human eye. First I will explain light. Light is a form of energy. Light is a form of energy with the help of which we can see. Light make things visible in almost all ranges. That is from micro level to from micro level to micro level. Now you can see light from 0.4 micrometer to 0.7 micrometer. If wavelength is between these two ranges, it can produce the perception of vision, otherwise not. Now, nature of light. Light is energy that travels in electromagnetic waves, in the shape of electromagnetic waves. Light is electromagnetic in nature, meaning it can travel through vacuum, medium, and empty space. The speed of light is 3 × 10⁸ meter per second. × 10⁸ meter per second. This is wavelength. This is amplitude. Amplitude is. Now, nature of light. Light consists of perpendicular electric and magnetic field propagating through space in a third perpendicular direction. Light has a dual nature. It is both particle nature called photon and a wave nature. We perceive the wavelength of light as color. Speed of light is given. The frequency of the light is inversely proportional to the wavelength and proportional to the energy, according to Compton effect. V is equal to F lambda, E is equal to HF. So frequency is directly related to the energy. Higher is the frequency, higher will be the energy. And the second thing is inversely proportional to the wavelength. Lambda is equal to V by F. So inverse relation, lambda is inversely proportional to the wavelength. Conclusion. The phenomena of interference, diffraction, and polarization applied are well explained by considering the wave nature of particle. On the other hand, interference pattern, diffraction, and polarization verify that light has wave nature. Light has wave nature. Light has wave nature. Compton effect, photoelectric effect, etc. require verify that light have particle nature. Bohr complementary principle state that wave and particle description are complementary ways. According to uncertainty principle, it is impossible to design an experiment which show that particles and wave nature are at the same time. Dual nature of light, photoelectric effect, refraction and interference, diffraction and refraction, diffraction and photoelectric effect. These verify dual nature of light. Dual nature of light. Light has dual nature. Light has dual nature. For example, properties of wave. It is wave property, it is wave property, it is wave property, it is wave property, it is wave property. Okay. This is particle property. This is also particle property and particle property. This is common. Diffraction, only wave can be diffracted, particle cannot be diffracted. Polarization is only wave property. Interference is wave property. If any medium or wave responded obey these are, if any phenomena take place, or if you have wave or if light they are diffracted, polarized, interference take place, you can say that these have wave nature. If Compton effect, photoelectric effect, these things are obey, cannot escape a black hole, so it's interact with the gravity. If it obey Compton effect, photoelectric effect, it verify particle nature. Reflection and refraction both are take place for wave and particle. Electromagnetic wave. Electromagnetic waves are the waves which do not need medium for their propagation. Electromagnetic wave does not require medium. For their propagation. Particle nature, wave nature. Magnetic field behave. If magnetic field is responded in this direction, electric field will respond in this direction. So electromagnetic waves propagate perpendicular to each other. Light have electromagnetic nature. Now again, nature of light is what? Light is transverse electromagnetic that can be seen by the typical human eye. The nature of the light was first illustrated to experiment on diffraction and interference. Like all electromagnetic waves, light can travel through vacuum. Light has dual nature. Sometimes it behave like a wave and sometimes it behave like a particle. For example, P is equal to mv. this is wavelength, and E is equal to mc square. So E is equal to mc square. E is equal to mc into c. E is equal to pc. P is equal to m. If this is equal to V is equal to C, it is equal to C. P is equal to E divided by C. Now I will write here, according to Compton effect, E is equal to HF. So in place of E we will write HF divided by this. E is equal to HF and divided by C. So and P is equal to, next page, P is equal to HF divided by C. V is equal to F lambda. Lambda is equal to V divided by F. So P is equal to H divided by lambda. So momentum is particle property. Momentum is a particle property. And wavelength is wave property. So according to this equation, particle can behave like a wave. Particle have a wavelength and wave have a particle. It depends on the situation which property dominate. Now come towards Huygens principle. Huygens explained the wave nature of light. He suggested that light propagates at a distance as a disturbance. He considered that each point of light wave cannot act as a secondary source of wavelets, due to which light propagates as a wave become possible. He predicted that light should propagate more slowly in denser medium. In optics, a statement that all points of a wave front of a light in a vacuum of transparent medium may be regarded as a new source of wavelets that expands in every direction at a rate depending on their velocities. The new position of the wavefront can be found after certain time by drawing a surface that touches all the secondary wavelets. So I will explain. First, Huygens said that dual nature of wave nature of light. He suggested that light propagate at a disturbance, spherical pressure wave. He considered that each point of light wave can act as a secondary source of wavelets. For example, if you have light source here, light travel in this direction. This is plane wavefront. This is primary source. This is secondary source, secondary wavelets. It will behave, the secondary source will behave as a source of light. Secondary wavelets will behave as a source of light, and propagate in a direction with a velocity equal to the initial velocity. So if a new surface is constructed, you can find the new plane wavefront by drawing a spherical circles like this. So you will open the compass equal to this distance, and draw a circle like this. On this point, draw a tangent line. That tangent line will give you the new wavefront. The new wavefront. The new position of the wavefront can be found after a certain time by drawing a surface that touches all the points. For example, S is equal to Vt, V is equal to C, and S is equal to D. So D is equal to Ct. So speed of light is known. If you know the time, you can find the distance of the newly constructed wavefront by this experiment. Now I will explain again. Light is an electromagnetic wave. Light is a particle. The photon, the nominal contradiction, is an example of complementary or duality in quantum mechanics. Depending on circumstances, it is probably to use one or the other point of view. Light, electrons, protons, atoms, anything which is too small to be described by normal physics and directly experienced required using quantum mechanics. Huygens principle. Every point of wavefront acts as a source of secondary wavelets. Wavefronts, as it develops, is tangent to their inverse. Wave versus particle. This is diffraction phenomena. This is also diffraction phenomena. This is diffraction phenomena. Here more dominant, here less, here less. Because here the width is less, so the diffraction will be more dominant. In this case, this is wavefront, and this is the secondary wavefront. This is the primary source. Each of these points is the source of spherical wavefront. These source, 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 source. Initial wavefront. This is the secondary wavefronts. These are the secondary wavefronts. Now students, light produce sensation of vision, dual nature. Particle nature and wave nature. Newton described that light has particle nature because it travels in straight line. Because light travel in straight line. Light travel in straight line. Huygens described that light light has light has wave nature. Light has wave nature. De Broglie explained that light has dual nature. Sometimes it behave like a particle and sometimes it behave like a wave. So in this chapter we have to study wave nature of light. Wave nature of light. Next lecture we will do experiments for this, and we will try to verify wave nature. Thank you, students. Allah Hafiz.